Okay, so now that you've learned that radioactive decay is basically where a large atom will break apart into smaller parts, and in some of the parts that release are called radiation, we're going to talk about the three main kinds of ionizing radiation. Okay, so some of them are very harmful, some of them aren't as harmful, and some of them are very penetrating, meaning they can go through several layers of different materials, and then some of them aren't. So let's talk about the three of those. We have alpha, beta, and gamma. So they all look like different things. So we know that right here, when radiation breaks off of a large atom, it can be alpha, which is two protons and two neutrons. It can be gamma, which is a wave, a high energy wave, high energy photons, or it can be a high energy electron, which is one negatively charged particle. So for alpha, it's two protons and two neutrons. If you look at your periodic table, you'll see two protons equals a helium atom. So ionizing radiation that is an alpha particle means that two protons and two neutrons break off. So how bad is that? Because we know this says this is the most harmful. It can only pass through paper. So you may be thinking, well, if it can only pass through paper, how can it be that harmful? We usually find alpha particles in things like smoke detectors. So when it releases alpha radiation, it helps detect smoke. So alpha radiation emitting elements have also been used to power some heart pacemakers and space probes. Um, but this is the most harmful. You definitely would not want to ingest this. And it's used in a lot of things that we see every day. Then we have beta. Beta radiation is just when one electron breaks off. Um, Beta radiation can go through paper and it is stopped by aluminum. So alpha was stopped by paper, beta will be stopped by aluminum foil. So like your typical aluminum foil. Beta radiation can be used as tracers in medicine inside the body, and it's also been used in cancer treatment. They've been used to find leaks in underground pipes and to gauge thickness in metals. So just know beta can go through paper, but is stopped by aluminum. Alpha is stopped by paper. Our last one, our high energy electromagnetic wave, is going to be gamma. Gamma is going to be the least harmful for you. It can go through paper, it can go through aluminum, but it is stopped by lead. So these are used in your x-rays, and so if you go to the dentist, you notice they put a lead vest over you. That's because the lead can stop that radiation from getting to your organs. So gamma radiation is used to sterilize medical equipment. Can be used in telescopes, and it's also been used in cancer treatment. So look right here. It says an alpha particle. We just said it's two protons, two neutrons. That means it's a helium atom. A beta particle is one negative electron, and gamma is just a wave, no charge in it. So right here, this is a better way to look at it. And just ionizing just means it rips electrons off of atoms. Non-ionizing means low energy, not very harmful. But let's compare the three. So we've got alpha, a helium atom, charge of +2, because think about it, it's got two protons. It's relatively large, so compared to an electron or a wave, it's a large type of radiation. It's very slow. Remember, paper can stop it. And it is most dangerous when inside the body. So you definitely wouldn't want these to be ingested. So beta is just one electron. It's got a -1 charge. Very, very small. They are fast. They're high energy electrons. They're not very ionizing. And when the source is outside the body, that's when they are most dangerous. You wouldn't want to be around these. And then the last thing is gamma. Gamma is an electromagnetic wave. It has no charge because it has no particles in it, just a wave of energy. Has no mass, and it travels at the speed of light. Not very ionizing, and it's most dangerous when outside the body. That's why we protect ourselves from this type of radiation with lead vests, or when they do x-rays, sometimes the lady will walk out of the room. So let's look at this. You need to do the uses and properties and look at the symbols for these. So I'm going to show you mine in just a second. Let's see. Okay, so yours is going to look like this when you complete it. Alpha particles have 2 protons and 2 neutrons. That means with 2 protons, they've got a +2 charge. They can be stopped by paper. It can also be stopped by your skin. And they're used in smoke detectors. They have 2 protons and 2 neutrons, same as a helium atom. These are your important uses, so be sure you have this on yours. For beta particle, you need to know there's no protons, no neutrons, just 1 electron. A beta particle is 1 negative electron. And it can be stopped by aluminum foil. So for your notes for this one, be sure you have they are a high energy electron with very small mass and used in medicine for tracing. Lastly, gamma radiation, no charge, no protons, no neutrons, because it is just a wave, and it can only be stopped by lead and concrete. So for our notes here, be sure you put that it is an electromagnetic wave. Sometimes we'll call it a high energy photon. It can be used to treat cancer, like for radiation treatment, and has no mass. So on yours is blank. You're going to drag the squares that are at the bottom. I put them right here. You're going to drag them to the right one. You're going to drag green to beta, yellow to alpha, and purple to gamma. So when I see, so I really want you to try to do this yourself before you look at this key and just go drag them, because we are going to really need to know this. But I just want to explain some of the answers here. So in your blank here, so the process of nuclear decay is called radioactive decay. Radioactive just means that these large nuclei is the word for multiple nucleuses. So if a nucleus has more than 83 protons, it's going to be so large to remember that our strong force will not allow it to hold together, and so it breaks down, which makes it radioactive. So remember my yellow or my alpha particles. So the most massive particle, what that means is the largest particle. This alpha particle has 2 protons and 2 neutrons. It's much larger than the 1 electron of a beta or the nothing of a gamma. It's only dangerous if ingested. Those are alpha particles. They're made up of 2 protons and 2 neutrons, alpha. Same as the helium atom, because if you look at helium, it's got 2 protons and 2 neutrons. Can cause illness or death if you ingest it. It's the least penetrating type. Remember, paper can stop it. Can be stopped by paper, and has a charge of +2. Okay, let's look at beta now. Beta is our electron, which has a charge of -1. Can be stopped by aluminum foil. It says a neutron decays into a proton. Don't really get into that, but we do have an electron breaking off. It's only dangerous if you ingest it. The particle is a single electron. It says a neutron decays into a proton. Again, can cause illness or death, and particles are faster and more penetrating than alpha. So these can go through paper. Alpha is stopped by paper. These are only stopped by aluminum foil. And lastly, gamma. Remember, gamma is our high energy photon. We can use this to treat cancer. So when you hear cancer patients going through radiation, they use gamma rays. So gamma has a charge, has no charge. It's the most penetrating form. You need lead or concrete to stop it. Can cause less damage as it passes through living tissue. This is why we can use it in human bodies. It's electromagnetic waves. It has nothing, no mass or charge, no protons, no neutrons, no electrons. It can cause illness or death sometimes if used in the wrong way. And it's emitted when alpha and beta decay occur. So it can kind of be tied in with it. And it can be stopped by lead or concrete. Okay, so try to make sure you get all of these in the right spot, and then you'll be good.